Thank you all for joining us today. We will begin the webinar momentarily. This webinar is being recorded and will be made publicly available. To reduce any incidental background noise or distractions, all attendees have been muted. We request that any questions that arise throughout the webinar be submitted via the Q&A function, and we will be sure to address as many questions as possible during the Q&A period at the end of the webinar. So we will begin today's presentation with an introduction from Kelly Visconti, the Crosscut Team Lead from the Office of the Undersecretary for Science and Innovation at the Department of Energy. Thank you.
Great, thank you. Good afternoon, everyone, and welcome to our webinar on the Floating Offshore Wind Shot and Deployment Goal. I'm excited to kick this off and open our presentation and the excitement we've got going on in floating offshore wind and the essential nature of clean power to achieving our climate and energy and security goals, and really being a leader for the world in this area. So again, Kelly Visconti, Crosscut Team Lead. I've been working with the Floating Offshore Wind Shot team and all of our energy Earthshots collectively to put together a portfolio of really innovative and hard challenges that we need to be successful. And I'm going to walk through our agenda and then introduce the energy Earthshots and some of our speakers. So if we go to the next slide, please. Great. So again, I'll cover really quickly a little bit about the Energy Earthshots initiative, talk about the 6 energy Earthshots we've launched, and then we'll deep dive into, no pun intended, the Floating Offshore Wind Energy Earthshot, and Jocelyn Brown-Saracena, our offshore wind lead, will take us through that and give more details behind the announcement that we've made on September 15th. And then we'll have Karen Baker, the Chief of the Office of the Renewable Energy Programs, from a key partner in BOEM in the Department of Interior, to talk through the Floating Offshore Wind Deployment Goal that was announced as part of an all-of-government effort to really drive floating offshore wind to success in the United States and for the world. We'll then turn to a question and comments period. We got a lot of questions during the registration, so we will try to address as many of those as we can. And again, if you have any questions, please put them in the Q&A and we will try to get through as many as we possibly can during the time we have today. So with that, I'll go to the next slide. Great. And yeah, we'll just go right into it. So what are the energy Earthshots? They are an all-hands-on-deck target that we are setting to go after the hardest remaining problems that we're facing to achieve our clean electricity goals by 2035 and a net zero economy wide by 2050. Our energy Earthshots are the things that are necessary, they're the things we must do to achieve these goals, and they're things that we must start working on and accelerate progress on over the next decade to be successful by 2035 and 2050. We're really focused on making a major impact in reducing our carbon emissions. We're talking about the hardest technology barriers, the things that are really challenging to go after, that we need that all hands on deck effort to do. We're setting highly ambitious but achievable targets. And really, these are meant to be compelling, bold, and inspirational. We need everyone to be working together to achieve these goals. And we're leveraging our past success in the model of the Sunshot Initiative. So all of our energy Earthshots are modeled in this way. We'll go to the next slide, please. So we're going to talk about the Floating Offshore Wind Shot today that was announced on September 15th. And the associated work with the deployment and the necessity and the way that research and development really goes hand in hand with deployment, and how these two pieces really are synergistic in the way that we evolve and develop technologies from idea to actuality and reality. Just to give a quick overview of some of our other energy Earthshots, the initiative was kicked off April of 2021. And our first energy Earthshot was focused on hydrogen. So this is clean hydrogen production, or $1 per kilogram in 1 decade. And hydrogen is an energy carrier. It is a fuel. It can be used in so many different pieces, and is really this cross-cutting approach for how we can decarbonize, and one solution approach to achieving our goals. The second is long duration energy storage. This energy Earthshot is focused on energy storage that is for 10 plus hours and focused on a 90% cost reduction in 1 decade. And this is really essential for addressing the daily and beyond daily cycles that renewable power has and make those more available as well as cost competitive for supporting our grid and providing the clean power that we need. The third energy Earthshot is focused on atmospheric carbon dioxide removal, carbon negative. We are targeting a range of pathways to remove carbon from the atmosphere. Models show that we are at the point where even if we basically turned off the sources of CO2 now, we've put so much in, we actually need to remove it to get to net zero. The goal there is technologies that can deliver atmospheric carbon dioxide removal for less than $100 per net metric ton of carbon dioxide equivalent in 1 decade. The sister shot to the floating offshore wind is enhanced geothermal. Again, driving down the cost of this really essential technology to help deliver electricity as well as the co-benefits of clean heat that we can use in industry or district heating. And we are targeting a similar time frame of 2035. And then our most recent energy Earthshot, announced just last week at the Global Clean Energy Action Forum, is focused on industrial heating. Fundamentally, we burn a lot of fuel to make heat, to transform the materials that make everything that we use, including the materials that go into our wind turbines. We need to have this virtuous cycle where we're driving out the carbon of the materials that go into our clean energy systems, and those clean energy systems are then used to make the materials that go into our everyday products. So our goal is to really focus on this cross-cutting area to drive out carbon dioxide emissions, greenhouse gas emissions by 85% through a range of different technologies that will help us address how we make metals, how we make plastics, and other really important materials. So that's the Energy Earthshots portfolio. These are the 5 that we've launched, plus the floating offshore wind, which we'll get into a lot more detail through the rest of this talk. But just wanted to give you an overview of how this portfolio is starting to paint a picture, delivering clean electricity, being able to store and transport it and use it in a variety of ways through hydrogen and other sources, and then thinking about the way we make things and then removing the emissions and addressing those hard to decarbonize sectors where we know we will still be relying on hydrocarbons and other materials where carbon will be put into the atmosphere. Next slide, please. All right, and so at this point, I'm going to hand it over to Jocelyn to take us through the details of the floating offshore wind shot. And been an exciting time to work with Jocelyn and the team, and pass it over to you.
Great, thanks so much, Kelly, and thanks for your leadership as we've worked to develop the shot. And before I dive in, want to thank you all very much for taking the time to be with us today, to join us for this webinar. And I also would like to thank our interagency counterparts. I'm here giving an overview of the floating offshore wind shot, but one of the things that I really want to emphasize, and I think is so important about this shot, is that it reflects the all-of-government approach that we're taking in the United States to advancing offshore wind, and is an interagency effort. So I want to thank my interagency counterparts at Department of Interior, and you'll hear from Karen Baker later in this event, but also our partners at the Department of Commerce and the Department of Transportation for their collaboration and partnership here. And I also want to thank the team at DOE and International Labs who helped with analyses here for their work in developing this effort. It really was a team effort that required a lot of work on behalf of a large number of folks who were really instrumental in getting us here. So I want to begin, before we start talking about the shot effort itself, spending just a little bit of time talking about what is floating offshore wind, what's the current stage of development with respect to floating offshore wind, both globally and domestically, and then why did we think here at the Department of Energy, why did we think floating offshore wind in particular was a good candidate for an Earthshot initiative? After that, we'll talk some more about the floating offshore wind shot, the needs that we hope that it will address, some of the planned areas of focus, as well as some of the work that we announced in conjunction with this initiative. So To begin, I think most of the folks on this webinar are probably familiar with this, but floating offshore wind technology allows us to access deeper waters than its fixed bottom counterpart. Fixed bottom turbines are the ones that we've seen deployed most widely commercially to date, where you've got a turbine that is attached to the seafloor, typically through a monopile or a jacketed foundation structure. And floating technologies, by contrast, allow us to access wind resources in deeper waters. Typically, we consider that the depth threshold to be around 60 meters. And in these systems, you have a turbine that's mounted on a floating foundation or substructure. And if we go on to the next slide, the majority of offshore wind that has been deployed globally around the world to date has been fixed bottom technologies. And just this past year, global installed capacity of offshore wind internationally passed 50 gigawatts. However, last year marked something of an inflection point for floating offshore wind. According to the Department of Energy's annual offshore wind market report, over the last year, the global pipeline for floating offshore wind more than doubled from about 26 gigawatts to more than 60 gigawatts. And that was accompanied by an impressive set of announcements from around the world for leasing commitments and installed capacity for floating offshore wind around the world grew to over 120 megawatts last year. And here in the United States, if we look closer to home, we are at the stages of beginning to plan for floating offshore wind development. You're going to be hearing more from Karen Baker shortly about the leadership role that BOEM is playing with respect to advancing the development of floating offshore wind. But I think it's also really important to acknowledge that states are providing a key leadership role for floating offshore wind development as well. Folks are probably aware that California published ambitious targets for floating offshore wind development for 2030 and 2045 recently, and states like Maine and New York are working on roadmaps and master plans for the responsible development of offshore wind. And Oregon recently, just recently, published an assessment of benefits and challenges for floating offshore wind development. And here in the United States, we have a really rich resource when it comes to offshore wind, both for fixed bottom and for floating technologies. And we are working really hard in the United States to advance the responsible development of both types of technologies, as was evidenced by last year's 30 gigawatt, the establishment of the 30 gigawatt target, and all of the work that we are collectively doing to make that target a reality. But this effort that we're here to talk about today is really focused on floating offshore wind. And so I want to spend a little bit of time talking about why that is. So about 2/3 of our offshore wind resource in the United States is over these deeper waters that would require floating offshore wind technologies in order to access that offshore wind resource. There are regions of the country, so if we look off our Pacific coast or the Gulf of Maine, where in order to access our offshore wind resources, we will need floating technologies. But also, if we look along other coastlines, as we go further from shore, waters get deeper. And if we want to be able to access those wind resources, we will need floating offshore wind. So the resource is really, the floating offshore wind is really national in scope. And if we go on to the next slide, so we understand that we've got a rich resource in the United States when it comes to floating offshore wind. And even if we were able to tap just a fraction of that power, we could, that resource, we could power tens of millions of American homes and businesses. And we know that we'll need a diversity of clean energy resources to reach our goals of decarbonizing the electric grid by 2035 and to reach a net zero economy by 2050. And so given the scale of the floating offshore wind resource, given its proximity to coastal load centers and its ability to help us diversify our resource mix, we think that it can be has the potential to be a key tool in our decarbonization efforts and also a key tool for helping us revitalize our nation's coastal economies and coastal communities. It has the potential to provide tens of thousands of jobs, spur investments in supply chain, and also provide economic benefits to underserved communities. So we recognize that there's a significant potential here, but we also recognize that there's work to be done to help us unlock floating offshore wind in the United States. We recognize that the technology is more expensive than its fixed bottom counterpart and is at an earlier stage of development. So given both this large potential and the work that we need to do to help unlock the potential for floating offshore wind, we really felt like, and given this inflection point, this moment that we're at with respect to floating offshore wind development, we really felt like the time was right, the moment was now for a big push to try to advance floating offshore wind as part of our clean energy future in the United States. So in acknowledgement of this, and if we move on to the next slide, we released the Floating Offshore Wind Shot on September 15th. And with this shot, we're really looking to help drive U.S. leadership in floating offshore wind design, manufacturing, and deployment, both, as I mentioned, to help us decarbonize our economy and revitalize our coastal economies. And with the announcement of the shot, we established an ambitious goal with respect to cost reduction for floating offshore wind, with a goal of reducing costs, the levelized cost of energy for floating offshore wind by greater than 70% in deep waters by 2035. And that corresponds to approximately $45 per megawatt hour by 2035. And as we were working on the analyses around this target, we also did some internal analyses around some techno-economic analyses with respect to prospective potential deployment that reaching this target could enable. And those analyses suggested that reaching this target by 2035 could potentially enable 120 gigawatts or more of just floating offshore wind by 2050. And so we think that this target has the real potential to have meaningful impact with respect to a scale of potential deployment moving forward. And we can move on to the next slide. So we're going to spend a little bit of time talking through what we see as the needs with respect to floating offshore wind development and the work that we are hoping to do through the shot to address those needs. But before we move on to that, I just wanted to take a moment to reflect on the scale of these systems. And what you see here on this slide is a 15 megawatt reference floating offshore wind platform with the White House for scale. And I think when I look on this, I reflect on both the scale of logistics, of manufacturing, but also the scale of potential resource power that we can provide. And I think all of these things, that the scale component, I think, is a really important reason why floating offshore wind is well situated, well suited for an Earthshot effort. So we can go on to the next slide. So as we're looking to advance floating offshore wind in the United States, there are 5 major areas of needs that we're really looking to. The first is, of course, cost reductions. We have a central cost goal as part of this floating shot, and I'm going to be spending a little bit of time in subsequent slides really talking through some of the areas of R&D that we think will be really important to helping us meet our cost targets. But of course, those cost reductions are not the only things that we need to do to help us unlock floating offshore wind in the United States. And also, as Kelly said, there is a reciprocal relationship between deployment and our ability to deploy and our ability to drive down costs. And for both of those reasons, we are looking to kind of a full complement of areas of need to address as we're looking towards this floating offshore wind shot. So first, I want to spend some time talking about expanded, just, and timely deployment. So we know that as we're looking to the future, we need to not only make sure that we're expanding opportunities for deployment, but we're doing so in ways that are environmentally sustainable and that allow co-users to thrive alongside offshore wind development, and allow communities to really benefit from development. And the Bureau of Ocean Energy Management and their partner permitting agencies are really leading the way here. But we at the Department of Energy are committed to bringing our resources to bear to help further these efforts. And through the shot, we aim to support research, information, tool development, and stakeholder engagement to help us both understand and minimize the impacts of offshore wind on the marine environment on an ocean co-users. Next, in order to advance floating offshore wind in the United States, we're going to need to ensure that we develop a robust domestic supply chain. We know that in order to advance floating offshore wind in the United States, we're going to need to both understand port upgrade needs and work to expand port capabilities. We're going to need to have a fleet of vessels available for construction and operations. We are going to need to build manufacturing facilities, and we're going to need to foster a network of tier 2 and tier 3 suppliers. And we're going to need to do all of this with environmental justice at its core. And we're also, as we look to develop a domestic supply chain, we're also going to need to ensure that we have a trained workforce that's really ready to step into jobs as the industry grows. And we're going to need foresight into the timing and geography of that growing demand. And it's also going to be really important that we work to ensure that we're doing everything that we can to ensure that that workforce and workforce opportunities are equitable, inclusive, and that we're supporting the development of a diverse workforce. And then finally, we're really going to need to work to advance and really revolutionize our manufacturing practices themselves, advancing our ability to serial manufacture a range of components, and really maximize the employment of domestic facilities in this manufacturing process. And I'm going to talk a little bit later about a new prize that we announced in the same week as we announced the floating offshore wind shot that seeks to advance some of these efforts. And then as we look to expand further development of floating offshore wind, we're going to need to resolve transmission challenges in areas adjacent to coastlines and ensure that we ensure that electrons can come onshore in cost-effective manners. And we're going to need to have solutions that help grid planners and system operators meet our goals to decarbonize the electric system, while not just protecting the resilience and reliability of the grid, but really enhancing system resilience and reliability. And we're going to need to usher in those solutions through planning, through analysis, and through R&D. And then last, we think that there is potential for floating offshore wind broadly, and including floating offshore wind, to be an important driver of economy-wide decarbonization. And so we really see the need for additional RD&D with respect to cogeneration applications of floating offshore wind, including clean fuel production, as well as coupling floating offshore wind with storage. So if we move on to the next slide, as I mentioned at the beginning, we are initiating this shot as an interagency effort, as a collaboration between Interior, Commerce, Transportation, and Energy. And we look to bring not only our individual agency capabilities to bear with respect to advancing floating offshore wind in the United States, but also look to coordinate with external entities, including states, the floating offshore wind industry, ocean co-users, community groups, environmental justice organizations, and others to really help us address the full suite of needs that I spoke to. And if we go on to the next slide, I do want to take a few minutes to talk about the technical R&D contributions that we think are going to be really important to helping us achieve the cost target associated with the shot. And there are 4 major areas of work that we think can help us make significant gains to reaching that cost target. And those include advancing serial manufacturing capabilities for a range of different system components, but with an early focus on mass manufacturing for platforms. And I'll talk about the prize. Again, I'll talk about the prize more in a little bit. The work that we can do to continue to develop larger turbines with higher generation capacities, the work that we can do to try to optimize systems or wind turbines and platforms as systems. So looking to optimize design from blade tip all the way down to ocean floor, and to continue to advance control co-design efforts as part of that. And then finally, the work that we can do to increase operational reliability, reduce costs associated with maintenance, and then also work that we can do to help advance circular economy and lifetime extension practices. So if we go on to the next slide. I just want to note that in a similar vein to taking an all of government approach to this shot, we also aim to leverage the complement of resources that we have within the Department of Energy to help advance floating offshore wind. So we have a range of offices that have expertise with respect and capabilities that will be needed as we seek to advance floating offshore wind. And part of what we're hoping to do with this shot is really coordinate them and bring them to bear to help us meet our ambitious targets here. And so we can go on to the next slide. And as folks may have seen, in association with the announcement of the floating offshore wind shot, the Department of Energy also announced approximately $50 million in new R&D funding. And that R&D funding really went to the range of different needs that I talked about on the earlier slides, from R&D to help us continue to advance technology and lower cost, work to help us assess port needs and plan for port upgrades moving forward, work to address transmission needs, particularly with a focus on the West Coast, and in this case, environmental research, work around ocean co-use and how we might work to co-design systems to ensure that we are accommodating ocean co-uses. And then also, I've mentioned a couple times our new floating offshore wind readiness prize. And if folks haven't already checked that out and have potential interest in this prize, I'd encourage you to look into it. What this prize will do is it will challenge competitors to optimize floating platform technologies and then work to get them ready for wide-scale manufacturing and commercialization. And we just are kicking off this prize, and so it's a great time to get engaged if you have interest there. And with that, we can go on to the next slide. So I do want to note that we announced this $50 million in funding, but this builds the new work that we announced really builds on both an existing portfolio of work that we have within the department with respect to advancing floating offshore wind, and that ranges from R&D for floating turbine and platform technology, a portfolio of environmental and ocean co-use work, and then also 2 different floating offshore wind full-scale demonstration projects off of waters off the East Coast. And then it also has the potential to capitalize on some of the resources that we have at our disposal with respect to building a better grid and supply chain development. So through both a combination of the bipartisan infrastructure law, the Inflation Reduction Act, as well as existing DOE programs, DOE has more than 20 billion in funding to help support the Building a Better Grid initiative. And that funding is available for a range of different applications. And then we also have resources that we're working on with respect to supply chain development, including the development of a national offshore wind supply chain roadmap, the development of a national offshore wind workforce roadmap, but then also the Loan Program Office has both an existing suite of programs and funding, but also received additional authorization through the Inflation Reduction Act that are also available for a range of different applications, and may have applicability here to for a range of different applications, from project development to transmission to manufacturing facilities. And so if folks are interested in learning more about those programs, I'd encourage you to look into them. And so if we move on to the next slide, I'd like to close with just a couple points here. One is that I want to really emphasize that we are committed to working with the broader stakeholder community as we work to execute on this shot. And as our next kind of major event with respect to rolling out the shot, we are going to be hosting a floating offshore wind energy Earthshot summit, likely in the early 2023 timeframe. And so if that's something that you're interested in participating in, please stay tuned for more information as we work to finalize details with respect to timing and format of that event. And before I turn it over to Karen, I just want to close in saying that at the Department of Energy, we're really committed to a vision of a future in which the sustainable and just development of floating offshore wind is a cornerstone of regional and economy-wide decarbonization and the revitalization of coastal economies. And I really want to thank you for joining us here today to learn more about the shot, and really look forward to working with you all to help make this vision a reality. And with that, I will turn it over to Karen Baker, who's the chief of BOEM's Office of Renewable Energy Programs, and we'll look forward to engaging with you with respect to your questions after Karen has an opportunity to give her overview.
Well, great. Thank you so much, Jocelyn. Really glad to be here. I'm Karen Baker. I am the new chief for the Office of Renewable Energy Programs, or what we call OREP, within the Bureau of Ocean Energy Management, or BOEM. My bureau is part of the U.S. Department of Interior. I want to thank you all for joining us, and I just want to thank our Department of Energy partners today for putting on this webinar, and it's great to be presenting with them on the recent White House announcements on floating offshore wind. I'm excited to talk to you today about BOEM's role in offshore wind and the new U.S. floating offshore wind deployment goal. Just a little bit about BOEM and our mission. It's our nation's natural resource. BOEM's mission is, our nation's natural resources provide unparalleled opportunity for energy and mineral production, job creation, and revenues for the American people. These opportunities can only be realized when these resources are managed thoughtfully. For those of you who are not familiar with BOEM, we are the federal agency tasked with managing almost 2.5 billion acres of the nation's seabed, nearly equal the size of the nation's land acreage. Our primary mission focuses on the responsible development of conventional and renewable energy and marine minerals with the best available science and traditional knowledge underpinning all of our efforts. And if you could move to the next slide, let me tell you a little bit about what we're doing in offshore wind. At BOEM, it's our mission to ensure that the development of offshore wind energy is done in an environmentally and economically responsible way. And as the chief of OREP and in our renewable energy programs, that's definitely my mission and what I am charged with advancing. BOEM uses a multi-phase process to grant access to ocean areas suitable for wind development. And I want to walk you through this very briefly just to understand the process and the extensive care that we put into ensuring that we are putting in offshore wind and we are permitting offshore wind in the environmentally and economically responsible way. So I'm going to talk just a bit through our multi-phase, our 4-stage process. In phase 1, the planning analysis phase, BOEM identifies potential areas for wind leasing. In phase 2, we have an auction held and the companies bid to win the right to potentially develop in that area. And that is what they win at that point in time. They win that right to potentially develop in that area. In phase 3, after companies are awarded their leases, those companies conduct surveys and studies to learn more about their lease areas. Then they submit a construction and operations plan for a prospective offshore wind facility. And in that last phase, BOEM conducts an extensive environmental and technical reviews to determine the possible impacts before approving, modifying, or disapproving the plan. After all 4 phases are complete, construction can finally begin. And I want to just make sure you understand that this all in all, this is about a 2 to 5 year process. And just to talk a little bit about the first phase of the process, since areas that will require floating offshore wind energy systems are in various stages of the planning and analysis phase right now. And we'll talk about those, some specific ones in a little bit later on. In this phase, which can take up to 2 years, BOEM uses rigorous scientific data and acquires environmental science and socioeconomic information about an area to determine which locations would be best suitable for wind energy development, which we call wind energy areas. And we actively respond to feedback from government partners and other members of the public to improve that area and identification process and to learn more that we can and to better scope that down. And that's something that we are working on consistently in terms of looking at our processes and how we can improve area identification. We're all about showing our work, explaining our rationale for what we're doing and identifying draft wind and energy areas when we put them out for comment. This update to our wind planning process not only provides stakeholders additional opportunities to contribute meaningful insight, but also contributes to a more transparent and inclusive process in identification. So that's going to be key, because as we start to talk about floating wind, these are the areas that we're looking at right now. We can go to the next slide. Just want to give you a little bit of an overview of the state of U.S. offshore wind as a whole. As the lead federal agency for offshore wind energy development, BOEM is advancing the leasing and regulatory processes needed to move offshore wind forward as part of the administration's goal of deploying 30 gigawatts of offshore wind energy capacity by 2030. To date, BOEM has made progress on new offshore wind projects and lease sales on the outer continental shelf, including the signing of 27 commercial leases off the East Coast. Moreover, BOEM has approved the nation's first 2 major offshore wind projects in the Atlantic. Vineyard Wind 1 and South Fork has initiated the review of 10 additional projects. We can go to the next slide. This gives you a little bit of a sense of where we are in the process of a number of these different leases. We intend to hold 7 lease sales by 2025. The 2 approved projects that I spoke about, as well as the project plans currently under review, all call for traditional bottom fixed turbines for lease areas in shallow water. So if we could go to the next slide, and we talk about what we're here to talk about today in terms of floating offshore wind. These are the areas that we are currently looking at for potential, and there are more that we are exploring. But more than half of the nation's offshore wind resources, as Jocelyn mentioned, occur above deep water ocean areas. So we have most of everything we're talking about until now. In terms of the extensive work the BOEM has done is focused on fixed bottom offshore wind turbines. And they're not economically feasible, as mentioned, in these deep water areas. The floating turbine technology is newer. It's less deployed worldwide than that of the fixed foundations. And so we're glad to partner with DOE and with others to learn more, to look at how we can address this and how we can bring more floating wind. We're excited to be part of the floating offshore wind goal of 15 gigawatts by 2035 deployment. We have been part of an initiative that the administration put in place to committed to deploy 30 gigawatts of offshore wind by 2030. And now this is, we're taking a step further with the 15 gigawatts by 2035. The administration's floating offshore wind announcement on September 15th builds on these commitments. It seeks to advance floating offshore wind, which is needed across the nation's deep water ocean offshore wind resources. If we could go to the next slide. As Jocelyn mentioned already, she showed the slide already, so we won't go into it too extensively, but this is the difference in the technologies. And the administration's floating offshore wind announcement builds on these commitments. We are seeking to advance floating offshore wind needed to access the nation's deep water offshore wind resources. It calls on the federal family. We're excited to be part of that team, that federal team, to leverage our collective resources to focus on floating offshore wind opportunities in the U.S. And this all of government floating offshore wind initiatives will grow domestic renewable energy capacity in the United States by driving U.S. leadership in floating offshore wind design, development, and manufacturing. In addition to an ambitious goal to reduce the cost of floating offshore wind energy, the Floating Offshore Wind Shot also includes a goal to develop 15 gigawatts of installed floating offshore wind by 2035. It's enough, as already has been mentioned, energy to power over 5 million American homes. And so we're excited to be part of this. And planning has already started in deep water areas like California, Oregon, Gulf of Maine. In fact, we plan to hold a lease auction for areas off the coast of California later this year as we continue to work on identifying areas in the other parts of the continental shelf of the US where we can employ this technology. Bringing floating offshore wind to scale unlock new opportunities for offshore wind power off the coast of California, Oregon, and Gulf of Maine, as I mentioned. And it facilitates this role in transitioning to the nation to cleaner energy supplies, can contribute significantly to already established state goals. And we're just proud to be part of this all-government approach. We're excited to join our colleagues at Department of Energy, Commerce and Transportation as we work collectively to advance a domestically sourced offshore wind supply chain, address transmission and other initiatives such as technology and development of floating wind. BOEM is committed to supporting the establishment of a durable supply chain in the United States that can sustain both the floating and fixed structures that developers will be using during the safe, expeditious, and orderly development of offshore wind. In conclusion, BOEM is trusted with the safe and responsible development of offshore energy resources for the nation, and we are privileged and honored to fulfill that trust in every day and every decision that we make. We remain committed with our partners to active engagement with ocean users, stakeholders, tribes to ensure the responsible development of those shared renewable energy resources on the nation's outer continental shelf. Thank you, and I encourage you to visit our website, www.boem.gov, for additional information, and I'm excited to address your questions.
Great, thank you so much, Karen. Yes,
And
folks.
Oh, sorry, Kelly, I didn't mean to cut you off, but I did want to, just before we dive into Q&As, refer folks to a number of different resources where you can find some more information on these efforts, including the Floating Offshore Wind Shot homepage and associated fact sheet, the White House fact sheet, as well as when the Department of Energy's Wind Energy Office issues funding solicitations or has advancements with respect to R&D, we include those in a regular newsletter. So I'd encourage folks to sign up for that. And we have received some questions about whether the slides would be available, and we are planning on posting a recording of this webinar linked to that Floating Offshore Wind Shot homepage. So just wanted to address that at the outset, and then we'll turn it over to you to help facilitate Q&A.
Great. Well, thank you both, Jocelyn and Karen, for the presentation and your leadership in this area. Really an honor and privilege to work with you all. We did get a lot of questions in advance, so we have a few that we're going to walk through. If folks could put their questions in the Q&A, and we'll again try to get through as many as we possibly can in this time we have remaining. So Jocelyn, the first question is actually for you. How do you plan to increase local engineering and fabrication content for offshore wind projects? You're on mute, Jocelyn.
Sorry. Sorry, hopefully you can hear me now. It's a great question, and thank you for it. There have been several recent federal actions that I think are going to be really helpful in this regard, both specifically and also will help support the development of robust domestic supply chain for both floating and fixed bottom offshore wind. So recently, the Inflation Reduction Act was passed, and that includes both manufacturing tax credits as well as additional domestic content credits associated with the clean energy tax credits. And those are both aimed at helping build and maintain a U.S. supply chain. And then I mentioned during my talk that in association with the SHOT, we launched at the Department of Energy a Floating Offshore Wind Readiness Prize, which is a competition that's meant to accelerate the market readiness of floating offshore wind energy technologies. And that prize will really seek to encourage collaboration between different types of companies needed to manufacture and deploy floating offshore wind energy technologies, as well as help teams optimize platform designs in order to enable local production and assembly within U.S. infrastructure capabilities and constraints. And then I mentioned that we're working on a national supply chain roadmap that will help us identify needs here and answer questions with respect to strategies to address how we help encourage local manufacturing. And then we also, with funding through the bipartisan infrastructure law, just kicked off a study with respect to port needs and potential upgrade opportunities with a focus on the West Coast. And given the logistics around offshore wind development and floating offshore wind development, we expect some manufacturing to be co-located with those ports. And we'll pass it back to you, Kelly.
No, that's great, Jocelyn. Thanks. My past life working in the advanced manufacturing office and understanding that the manufacturing supply chains are a really critical part of all of our technology development. So definitely a big area of emphasis within the SHOT and the research that we're doing in DOE across the board that can be really supportive of this, and the need to be able to do this at scale is really essential. Great. Next question. Shifting gears a little bit, Karen, I think this one's for you. Are there any plans to streamline the permitting process for offshore wind?
Well, thanks, Kelly. That's a great question. I thank the person who submitted that one, because this is something that is a huge focus of mine personally and BOEM in terms of how we can better streamline the permitting process. As you saw, the phases that I laid out there, it's a long, extensive process, and that's just, it's not just what BOEM does, it's also work that we have to work with our cooperating agencies and regulatory agencies that like the National Marine Fisheries Service, U.S. Fish and Wildlife Service. We work with the state regulators, and as well as taking stakeholder input all the way through those processes. And we're continually looking for ways to streamline what we're doing. We want to make sure that this is a process that's credible, that is transparent, that we are that everybody understands every step of the process. But we are looking to streamlining as much as we can. Most of the projects that I shared are in the what we call the Fast 41. So they are reviewed and monitored by the President's Federal Permitting Improvement Steering Council, which means that we report on how we're meeting our milestones. And so we have been implementing a number of things. First of all, part of it is this interagency collaboration that we're doing. We're coming together and looking at how we can align schedules, where we can find efficiencies in the process. We're working very closely with our applicants so they understand what they need to have. We are starting to put together, and we should be announcing very soon, some guidelines on when we need information so that we can better streamline our processes. And we want to make sure that when is done in a way that supports administration's goals of transparency and efficiency. We have to do it in a way that is environmentally protective and incorporates all the inputs from our ocean users, tribal, state and communities. But we can do this in a way that will. We've identified a number of different ways where we can start to streamline that process and find those efficiencies as we do that. And we're continuing taking input on how we can do that and get better at it.
Great, Karen. Thanks for that. Thanks for your efforts to make it more efficient. Certainly a goal for all that we aim to do, at least in the areas I've been working in the government. Part of our work in the Earthshots and the crosscuts are to bring efficiency, to align the resources, to do the communication, and make it as streamlined as possible to be solving the challenges that we're facing. Great. Next question. I think Jocelyn, this one's for you. Though Karen, you can certainly chime in. What are the depths of water we're talking about for floating offshore wind, ranges, average, and is the power cable also suspended off the bottom? So talk a little bit about how we connect to these systems. And Jocelyn, it wouldn't be a webinar if we didn't have at least one, hey, you're on mute throughout the whole process. So we check that box. We're good.
Well, hopefully it'll be just that one time. So yeah, and thanks for this question. And maybe it's an opportunity for us to dig into a little bit with respect to our cost analysis too, since we may have some folks on the phone who are interested in some of the details there. So typically, we consider floating offshore wind will be deployed at a variety of depths, but typically we consider, when we do, for instance, our technical resource assessments, we consider the depth bounds between 60 meters and 1,300 meters. Water depths in some parts of the United States, our continental shelf gets deep really quick in some areas, including off of some parts of the Pacific coast. And so we have some water depths that are going to be deeper than initial deployment depths than we've seen for some of the first projects that have been deployed internationally to date. And as we look to those deeper waters, we need to design anchoring and mooring systems associated with those deeper water depths. We'll need dynamic cables, and we'll also need, when we get into those very deep waters, floating substations as well. And with our to dive into the shot cost analysis a little bit, we tried to center that cost analysis around a reference site that would represent kind of the range of unique design conditions that we have in the United States, or design conditions that we need to address here in the United States. And so we used for the reference site for that target, that cost target, a reference site at 1,000 meters of depth and at 125 kilometers from a point of interconnection, so that we can consider kind of the work that we need to do around things like transmission solutions for long distance transmission, as part of kind of the technical work that will go into helping us meet that cost target. And we really want to make sure that we're optimizing these systems for kind of the range of deployment conditions that we have in the United States. And we'll pass it back to you, Kelly.
Great. Next question. So just coming off of the Global Clean Energy Action Forum last week, where over 6,000 folks registered, and I think over 4,500 people attended. Don't quote me on the exact numbers there, but showed up in Pittsburgh to talk about the international engagement that's necessary to solve this global problem. And Karen, I'll open it to you, but Jocelyn, anything that you want to add in here, please. Question is, what are opportunities for international collaboration?
Well, thanks. I'm glad to speak to that because we're learning every day from our international partners, and BOEM has established an international program that's developed strong relationships with offshore regulators. In fact, we have a forum next week in Denmark that we're partnering with the Danish Energy Agency. We're bringing together, which we call the Global Offshore Wind Regulators Forum. And this is a forum that meets regularly to talk about those issues and to share information and have a technical exchange. We're trying to take those lessons learned, those best practices, and apply them here in the US, and we learn a lot from them. So we've got people with key governments from sectors within UK, Scotland, Norway, France, and many others. And we have a number of bilateral exchanges related to floating wind specifically, so that we can learn from our partners in Europe and elsewhere who are already looking at this, and we can take the best practices and the best lessons learned from those who are already looking at the technology and leverage where we can and collaborate where we can.
And I would just add that from an R&D perspective, we do quite a bit of collaboration in the offshore wind space. We have an Office of International Affairs, and then within the Wind Energy Technologies Office, we're very active in the International Energy Agency's R&D collaboration areas on just a whole host of topics, and see that work as being really important to the advancement of offshore wind moving forward, including floating offshore wind.
Great, thank you both. Next question is moving back toward the technical realm on energy storage, and this actually kind of connects in with our long duration energy storage Earthshot that we announced last year. But Jocelyn, we'll start with you on this one. What kind of energy storage and capabilities do floating offshore technologies use?
Great. Yeah, thanks for the question. I had mentioned that kind of one of the 5 areas of need includes a focus on cogeneration and energy storage, and that's an area that we see a lot of promise in, both the potential to couple floating offshore wind with storage, but also to couple floating offshore wind with secondary energy carriers. So using floating offshore wind to use to be used to generate clean fuels, particularly hydrogen. And those fuels can be transported pipelines or marine vessels. They can also be used in the context of maritime decarbonization, heating, and industrial processes. And so I think that there's both the possibility for energy storage in the form of various types of batteries, but also in the form of flywheels, compressed air, geothermal energy storage, et cetera, depending on the geographic region. But then also in Europe and elsewhere, there's been some really neat work that's being done to integrate offshore wind with various forms of other applications, including hydrogen cogeneration, energy storage, and other applications. And I think that's an area for additional consideration in the United States as we move forward.
All right, great. Karen, please go ahead.
Oh, all I was going to say is I think Jocelyn's answer just demonstrated why it's so important for us to have this whole of government approach. We're so grateful that the Department of Energy is looking ahead on this and is part of this process. So we're going to need those questions on storage answered as we continue to permit and bring offshore wind into fruition here in the United States.
Great. Well, we are coming rapidly to the end of our time. One closing question. You each have a minute left to answer. It's really about how do we achieve these goals and what processes and internal policies do we have in place to support the goals. So Karen, if you want to talk about the deployment goal under BOEM and what you all are thinking about, and Jocelyn around the R&D, D&D cost target that we have for the Energy Earthshot. But Karen, please.
Well, I think one of the things that we're grateful for in terms of BOEM and is that we have those processes in place. We've already started to work through this with the administration goal that we took on last year of achieving 30 gigawatts by 2030 of offshore wind. We're just building on this with this new goal and very happy to bring floating technology into the mix. As we said, it's a mutually supportive goal. We have the processes in place already to start to work to how we permit. We'll continue to refine those and in partnership with our federal team here and with input from our stakeholders. But I think we're well positioned to move this administration goal forward.
Yeah, and in recognition that we're almost out of time, I'll just say very briefly that I think what we're really looking to do here is to build upon the R&D and capabilities that we have underway and that we're kicking off now to really systematically work to address the needs and challenges, but then also really fundamentally to work both with our sister agencies and then with a suite of relevant stakeholders in order to realize our objectives with respect to this shot.
Great. Well, thank you all so much for joining today. Thank you to Karen and Jocelyn for your time and presentation. Again, your leadership in these areas. As Jocelyn mentioned, for the Energy Earthshot and in partnership with our interagency colleagues, we will be planning a summit. Each of our Energy Earthshots has had a forum where we bring together folks to have a deeper conversation and a more interactive conversation around the challenges, the barriers, the needs, where we need to go on each of these targets as we build out a decadal plus plan to achieve the goal and really drive these forward. So I don't think there are any other administrative points. If there is, I'll just pause here. Okay, great. Well, thank you all again. Have a great rest of your day. I appreciate your support, time, and attention. Take care.